yung legend. Wala na. Yung HRL mo sa legend yun. Nag-12 years sa back. Ito mga legend. Pero baka na ng autograph. Minsan makita to. Sa kaya, naka-legend.
Si Dennis, sila yung CSR. Dami ko na yung kapwa. Ano? Gitna. Nasira yun.
Saan gagawin?
Wala na, mainit. Ay, naka-25 kilo. Three different locations.
This is for Zoom meeting, FB Live, tsaka YouTube.
Oh, wow, Zoom.
More application. Zoom meeting.
Different applications.
Hello, good afternoon. Good afternoon. So today, this afternoon, I'm going to discuss, maybe we share some my knowledge, my experience, and then you may tell me something which you guys don't know. We just share each other, okay? Today I'm going to, first of all, I'm going to tell you, for example, system design. Okay. This is one of the very typical system design for our system. Maybe all you guys are quite familiar with this, right? Yeah. So what do you mean? Then someone softener our system. Maybe somehow you send someone ask you, hey, Spencer, I would like to have our system permit water maybe 44 GBM. Can you give a quote? That's it. And then you need to do all the job. Maybe from the water tank, pump, centrifugal, carbon filter, softener, up to RO. You need to give all the information, all the details, right? Number one, customer gave you what information? Only how many GPM or flow rate. Let's say 44. Nothing, right? Then you need to know, for example, there's an RO, there's a recovery. It doesn't mean that 44 GPM system, your RO, this one, 44? Of course not. No. Of course not. Depends on what? Depends on the recovery. Permeate and concentrate. Right? We call it recovery. If you want to design the RO, 75% recovery, 60% recovery, 50%, which one? All depends on you. All are related to affect to your system design, all the way up to your home. Am I right? So that's why you need to know, define your RO system, what is your recovery. For example, most common for industrial, 75. What is the flow rate for softener, like the carbon filter, percent? What is the flow rate for this one? Anyone can tell me? 44 GPM? Of course not, right? What's the minimum flow rate? If the RO recovery, 75%. 44 divided by 0.75, right? This is your feed water RO, right? 50.
Sabi mo.
59, okay.
Ito makikita ng viewer. Yan makikita ng viewer sa
That's the flow
Meron
rate.
pa palang ganito.
That's the flow rate 59, right? For sand filter, carbon filter, softener.
Nakikita mo.
Single column, I mean single tank. Okay? In Asia, most of the customers they very direct or 15 times GPM, then I design tank and can carry 59 GPM. Okay? But in somehow some country, in Europe, in USA, they may divide it by 2 tanks. Become a multi-tank system. This is some benefit. But today I'm just focusing on install. So you need to select a pump. That pump are related to, as I mentioned, pressure. What is the pressure for the drive passing through sand, carbon, salt until to here? And then you may have 59 pressure minimum 60 psi, for example. We assume this one, let's say 10 psi drop, another maybe 10 psi drop, 10 plus 60, at least 90. Right? So you can select the pump based on this information. Okay? So today I'm not going to, actually, pump is very important direct effect to your sand filter or softener. Because maybe you are familiar to the pump curve, pressure, flow, right? If you look at the pump plate, what information you get? Maximum flow, and another maximum pressure, right? But these two numbers cannot tell you, cannot help you to design or select the proper pump, because I need 59 GPM. Can I just find a pump with 59 GPM? Not exactly. I need 90 psi, right? Can I just find a pump with maximum pressure with 90 psi? Of course not. No. Because you need to match with the pump curve. Right? 90 psi, flow rate 59. Then this is the best pump curve. This pump number, this is your select pump. According to the information. Okay. I'm not focusing on this one, so leave it here.
Tanggalin mo muna.
Okay, back to sand filter. So right now we need to sizing. How big the tank diameter in order to select the proper tank, right? Right now I only have this information, 59 GPM. How to size it? 16 inches diameter, 36 inches diameter, or 48 inches diameter tank? I don't know. Here, maybe today you all have some peanut, right? There are some very important information inside. We call it linear velocity for the flow rate or for surface flow rate.
Air.
Sand filter.
Password.
We have a design, we design for water treatment, or drinking water system, or this where we are working on the water treatment. For the sand design, we normally design take to 5 to 8 GPM. This is for sand, most of the sand filter applications. We're using this parameter. For activated carbon, depends on what kind of substance you want to remove. Activated carbon can remove organic, can remove chlorine. If your water already not too many not too many organic, then you may design more acoustic. But if you would like to remove very high organic level, your design may be down to 3 GPM, up to 8 GPM. Gallons per minute. In your setup, all this data is not, I said, from the information from the manufacturer, the mineral manufacturer, they provide all the information. I just consolidate it and then just let you know all the key. This is for surface art. For softener, all calculation. All calculation. I don't need to really rely on, hey, maybe someone, hey Spencer, I'd like to get 10 tons sand filter. Can I give you can you estimate how big the sand filter, the size of the sand filter? I don't need to really need to refer, I just have a calculator. That's it. I have a calculator. I can base on this information plus your service flow rate. Then I can calculate the diameter of the tank. Okay. This is just a calculation. In the leaflet, we have in the header we have some this kind of calculation. Okay. This three parameters, sand for sand velocity, for the activated carbon velocity, and the sand softener are most important. If you remember it, you can go anywhere and then you just using the calculator to calculate for this one. In order to calculate the diameter, so we need to know the area, surface area of the tank. Back to elementary school, you remember this formula? Right? Area equals to pi times r squared. Okay, elementary school, all know these formulas, okay? Based on that, because right now I need to calculate the diameter of that. Diameter related to radius. Okay? So we have this one. We have this one. Anyone can tell me? This one we know the area, right? Based on this. What is the value? What is the value?
1 r squared.
For example, if you take GPM, I would like to check the area. Anyone can hear me?
Huh? Ay, that's the value of 3.14.
Ano?
3.14.
Tabi kami ni
Diameter.
Oh, yeah.
Area. Reduces. Diameter. Volume.
'Anyone can tell me the answer?
We're looking for the area or the
Because I need to calculate the diameter.
diameter.
Yeah, I need to calculate the diameter. But I have this surface flow rate which is 5 to 8 GPM per square foot.
The area.
And then we have this flow rate. What is the area? What is the surface area?
Area.
So this is the area. Area of the tank. We have area 7.4 from 3.14
Wait.
square. Okay. 7.4 divided by 3.14.
Divided by 3.14. Square root of.
The unit is 1.53. Oh, 5. 5.3. The unit is 50. This is the radius. This radius times 2. This is diameter. On 3.06. So this is the size of the tank for sand. Yeah. Times to 36 inches. Yeah, 36 inches. So that's why we have to calculate. We know the size of the sand filter. When it's an inch sand. So you just think about your design in the past. If you would like to achieve this kind of flow rate, you look back maybe more or less the same. but you didn't know why you select 36 inches only. You just read on the table, your Bible, and then, but you never really think about it. Oh, that's 36 inches tank is come from by just simple calculation. Okay. Number one, we know 36 inches tank. Carbon, you look at here, depends on if you would like to remove the organic or the chlorine. If mainly for the chlorine removal, maybe we can go up to here. But if your water with a high organic, I prefer using lower grade, maybe down to 5. In Asia, what I observe nowadays, do, re, mi, all the stuff, all that here, they all design the same. Actually, it's not correct. More technical should be filter this size, carbon should be a little bit bigger, maybe up to 42%, in order to better to remove the organic, because linear velocity across the activated carbon has to be slower in order can the organic, the activated carbon can trap the organic, absorb the organic. Okay. So anyway, if you design using 8 GPM, the same. So also 36 inches tank. Okay. Now back to softener. Again, we need to calculate. But right now the data 10 to 15. Normally, I would like, I take 10 GPM as the design weight. So, by calculation, the size will be maybe just only 24, maybe no need to up to 36, maybe need to check. Again. Anyone can tell me the radius or diameter? Because you really calculate, then you remember in future. You just check. The diameter? So the floaters, we have no choice. We are in the market. FRP tank, we don't have 32 inches, 33 inches, so we have no choice. We select 36 inches. Okay. Okay, this is first step only. This is the backwash flow rate for sand, carbon, and softener. Okay. We need to know the proper backwash flow rate for sand filter, the proper backwash flow rate for activated carbon, the proper backwash flow rate for the softener in order to select proper size of drain line flow control. We know 36 inches diameter, and then we calculate the flow rate. Right now, this time we backward. We backward. For surface, we calculate to this side, right? Right now, we calculate backward. Anyone can tell me the backward flow rate for sand filter in this system? 36 inches diameter, meaning you know the area, right? Calculate the area times 10 or up to 15. It depends on the design, it depends on the medium. The area equals to GPM. This is the backwash flow rate for sand filter in this case. Carbon.
Try ko lang. Lock kasi minsan.
So we can help you to select the proper dramatic control in this system. Okay, 70 GPM on,
Ayaw man.
56 GPM, 25.
Lang.
Okay, so based on all the information, and then you check
Reconnect lang ulit siya.
which model can compile, can meet this one in surface flow rate, backwash can achieve. You can select the proper one. Without such information, you know nothing, and then actually you select which is maybe you cannot just select the bar based on the 5 inch or 2 inch bar or 3 inch. It's okay, no.
Nawala yung video sa.
Because such flow rate, you remember the CV. In the morning, we talk about the CV, right? We have flow rate, we can check the delta P. We can calculate that the delta P per this bar in this system. If passing through 7 GPM, what is the CV? And then you can check, oh, what is the pressure result for the bar only.
Nakuha nyo? Tayo nakakuha? Wala. Sir, can we request way back to the what we did competition? First.
How to
Can we show the step by step competition? Show can you show the board all the same competition?
Come on. I understand everyone, hey, Spencer, I would like to have a table. That's the table. But you somehow you
Ayaw,
go
ayaw
out
sa
and then someone
table
call
na yun.
you, hey, I would like to know.
Makita.
You need to know the root.
How did you come up with that?
Yeah.
So let's say compare everyone. Let's show Oh, sir.
Ano ang meeting yun?
Because everyone is not in the
I'm not finished yet. Okay.
Okay.
So based on this information, we can properly select the green light flow control per each system. Okay, percent for the carbon and so on. Okay. The valve not designed yet. We are not select the valve yet.
Yeah, we have done
Right?
that.
Select the valve, we need to check manual, check our specification sheet in order to match all the information. Okay. Send carbon quite strict direct, which is okay. Meet this one. Meet this one. That's it. Because I understand, based on your design, you need to balance between your cost. Yeah, the cost cannot be eliminated the cost as low as possible. And then the flow rate as much as possible. But you need to balance it, right? So somehow you need to fully understand the design, especially the pump. The raw water pump I always emphasize, this pump a direct effect to your system. How it works. Very
Ano ba yung
important.
problema
Because
dito?
somehow you are no choice to emphasize a little bit. You
Tanggalin
need
mo muna
to
sa TV.
find somewhere to compensate. Maybe you need to design a bigger pump, for example, in order to compensate or somehow this softener tank may be under design or over design because some of the limitation. Sand filter, you select the valve quite straight direct. Carbon. Straightforward, no problem. Softener. We have, right now we know this is 36 inches based on big head, okay? And then, how can you calculate how much resin you put inside the softener? Based on your experience. Oh, this size, 30 cubic feet. Based on your experience, oh, based on the Bible. Your Bible. Normally, we design for softener. The resin bed, right? Inside the tank. We pack maybe 50%, maybe 2/3. Anyone can tell me why don't we pack? Why don't we put full pack? Why? For my water. Correct. Have you ever heard counterflow? Some design. Some water treatment company they design full pack. Or maybe countercurrent. Do you know? Have you ever heard countercurrent or co-current system? Right now, our system normally co-current. Surface flow this way. Countercurrent, which is regeneration, also this direction, right? For example, softener. Regeneration, the salt, also this direction. We call it co-current regeneration. Some countercurrent, meaning your surface this direction, countercurrent, the brine from bottom to up. There's an advantage, a big advantage, but a lot of criteria. So most of the design in Asia, we design the softener co-current downflow. Surface downflow, prime solution downflow. Okay. Someone mentioned maybe we put 2/3 of resin, or maybe 50% only. Because in order when we backwash, we would like to have a space for the resin bin to wash. Okay, proper backwash. Okay. Based on the area, so that's why we know how many liters of resin to put inside of the tank. Again, elementary school formula. Okay, again. Again. So more or less, you know how many liters of resin should put inside the system. Okay. Why I need to know this? Because according to our Fleck, we need to comply of the flow rate, 59 GPM flow rate, the surface flow rate, or we need to check the backwash flow rate if the valve can meet the spec of 25 GPM. The third, check the ejector size if it can meet to regenerate this amount of resin. Some design, some bad design, small valve, small tank with big valve. Waste a lot of salt because of too much regeneration. They use too much salt, too much salt solution, brine solution go inside the system. So that's why all we need to learn. Okay, so that's why we need to understand or know the reservoir.
Huh?
We need to combine all.
Yung monitor kaya. Kalawin nila.
So up to now, any question?
Yung monitor. Yung gagawin yung monitor.
Ay, formula na yung game. Nakakalito eh.
Tayo yung gagawin yung slideshow.
Naglalokso eh, kaya lokso din tayo.
So those
Kung absent na naman siya kapatay. Balik ka na.
That's how I want to look at the areas. Surface area. That's the area. Diameter times height. Time is to move. Ay, sir, the rest is extremely going to clear. If I'm going to complete the volume of the rest and the express meters. How much cubic times that?
how
Times two.
Times two.
How many
how many salt?
How many resin?
How many resin?
Again, 30%.
Yung volume liters na yun.
Liters na ba?
Liters na volume.
Liters. Okay, okay.
So maybe we talk back to my slide, okay? You know, why we need to add the softener before the RO? What's the purpose? What's the purpose? Salt water. Why we need the salt? Why membrane need salt water?
To know when we will regenerate.
Why you need
Why we need the softener? Limit the hardness, correct? Have you ever seen some power system with the softener? With the softener. Criteria, your recovery has to be very low. If you design your RO, I like to design the RO recovery only maybe 30 to 50% only recovery rate. You may not really need to have a softener. It's such application. Because not easy to follow membrane. Not easy to follow membrane because of low recovery. But you would like to get achieve high recovery, you must have softener. Okay? understand, the hardest to damage the membrane, foul the membrane. Okay? So we are resin. Okay. Okay. Sodium. Ion exchange process again, using the sodium chloride to retain the resin, and then to become a salt water, which is the water which is full of sodium ion and the rest of the ion. Okay. Do you know, or maybe someone, if someone know, if I retain the resin not using sodium chloride, if I'm using hydrochloric acid, what will happen? For what application? Oh, for, not for this design, not for RO. Oh, it was the resin. I mean, trying to recover the resin because of fouling of the iron. Yes, you're right. Another which is the resin is not only for softener, the cation resin. Right now you're using a strong acid gel-based cation resin. This is not only for sodium chloride. Regeneration also we can use hydrochloric acid. But if such application, if you can combine with another column, another resin called anion resin, we can get the mineral water. Okay. Right? The major water composition in raw water. Before one, we need to remove it, and then soft water after passing through the softener. This composition will be full of sodium ion together with this part. Okay? The meaning which is TDS wise, you know TDS, right? Total dissolved solid. Before softener, after softener, is there any change? Increase, decrease in terms of TDS?
No, sir.
More or less the same. Or even a little bit higher. Yes. Because after softener, this one passing through softener, the TDS, total TDS, maybe a little bit going up. Never go down. Never go down. Never go down. Maybe same or a little high. Okay? Why? Because all the iron is still there. All the iron is still there. And then 1 calcium, 2 sodium ion. Maybe the conductivity may go up a little bit. Okay? As I mentioned, the DI, if I go by the resin, which is charged sodium ion, hydrogen ion, hydrochloric acid. So this portion come up hydrogen ion plus this portion of ion. I mean DI. Hydrogen cation resin reagent with hydrochloric acid, anion regenerate with this one sodium hydroxide, OH. So that's why after DI, anyone still doing this kind of DI system in Philippines? Okay.
Yes, we have, but for industrial is only.
For industrial.
For industrial.
For industrial.
Yeah.
For
What
ultra
about
pure water,
you?
for ultra pure water application or
For-
for plating?
But what about use? We use only
Semiconductor.
sodium.
Okay.
Semiconductors. They
Okay.
use acid.
Of course.
Semiconductors.
For semiconductor, they
Yeah.
are not that simple.
Mm.
Much more complicated using the mixed bag.
Yeah.
Mixed bag, the water quality up to 18 micron, this level.
Mm.
Okay, it's for semiconductor. Of course,
Yeah.
much more complicated. Okay. So, this, if in case fouling the membrane by iron, using hydrochloric acid can rinse, can wash the rest. After wash and then sodium chloride again in order to make it regen the resin. Others, which is depends on what do you mean, what was the meaning by hardness? What level? Classified as hard. What level? Classified as soft. So there's a table to tell you. In Philippines, I don't know what's the hardness level in Metro Manila. Any
300.
Depends on the area, sir.
Depende
Some
on
source
the
water.
trend 200?
That's source after.
200 is quite high then. 200, if more than 200 is quite high hardness area. So maybe you will have chance for boiler applications, RO system. You must have a softener there. Some company they claim, oh, I have a softener which is saltless or some magnetic type. To me, maybe work for a couple months. Maybe later on it's the same, and then you found your membrane found from your arrow. So the basic, the cheapest way, ion exchange method. Ion exchange method. It is the cheapest way. No other choice. Okay, some softener. Okay, again, fouling because of the iron, manganese, chlorine. Because for this system, we already have this one. So that's why protect our resin, our softener. Actually, this one, the main purpose is protect the membrane, right? Because the chlorine attacks the membrane. Very serious. So that's why you must have activated carbon in order to protect the membrane. So this one you can skip. This surface one you can read later because I already summarized all these by just now the calculation. All these the same because the calculation is as simple as here. Okay. Anything okay, this is the cross-section area.
Yes, reference for the tank area. Because if they have the tank area, then they can immediately see the tank diameter from here.
Okay, talks about salt dosage. Anyone know what is meant by salt dosage? What is meant by salt dosage? Resin. Yes, how much salt do for the regeneration per cycle? Yeah, according to resin manufacturer, we have different level of soft dosing. For home application, for home use, if the softener for home, we may just only use 6 pounds, 8 pounds of salt per cubic foot. Very small amount of resin, because I don't mind after regeneration, the salt water is not that salt. You need to really hit down to 0 ppm hardness for home applications. For industrial, RO system, for sure you will use the highest one, 15 pounds, in order to achieve the biggest capacity, the highest capacity, and achieve the very pure, very high level of soft water, meaning 0 ppm of time. Okay?
You mentioned service cycle.
So yes, because but in return you need to use more salt. Can you imagine? For normal applications for home, we use 6 pounds. We can get the grains. I mean the capacity, 21 kilograms. 6 compared with 15, almost 3 times, right? Or maybe 6, 2 times, right? 6, 12 pounds, 2 times of salt. However, the capacity not double, from 21 kilograms to up to 29 kilograms only. They are not double. So that's why. Even though up to 15, so that's why we are for the if this one the highest efficiency. This one the highest capacity. This one is lowest, highest efficiency, but lowest capacity. For industrial, if all you guys all pay around industrial application for RO, for the boiler, then use the max. Use the max only. Because otherwise, after regen, maybe you cannot achieve up to 0.03 ppm very low. You need to be close to zero, down to 0. Okay. Okay. Talks about capacity. I don't know if someone asks you, hey, you just install softener. If someone asks you, hey, may I know how often you need to regen the softener? How many days per regeneration? Do you know how to calculate? Capacity consumption, and then you need to know the flow water harness parameter flow rate in order to calculate how many days per regeneration. This is a very common question that end user may ask you. Of course, you automatic our or we set if by volume, yes, we can set. And then our system, our can calculate, especially for the electronic one. They calculate how many, after you run how many liter, and then you trigger the regeneration. But back to the basic. How to calculate? Correct. Very good. So because the resin we have, the can resin we talked about the capacity, huh? According to the so-called resin manufacturer, they have the spec sheet. They will highlight 10 pounds, the capacity, how much? 12 pounds, how much? 15 pounds. How much? It is all resin manufacturer. They will indicate. They will tell you what is the normally 15 pounds. They will get 55 kilograms. Because one bag, 1 cubic feet of resin, if I use 15 pounds, then you can get 35 kilograms of capacity. That's carbon. Okay, based on this information, for example, your raw water, 200 ppm, for example, what is the grains per gallon? Divided by 17.1. And then so, 11.7, right? Okay. Grains per gallon. You have this one. We have how many liter here? You backward to my softener design for 36 inches. How many liter of resin did we calculate? Simple show how many. Okay, quick check. Just how many simple. 36. Don't have. Then calculate.
Meron lang. Sa katawan.
Kanila lang.
Meron pa rin.
Jen, captured. Meron na.
Ana. Sila natin. Kasi yung table lahat yun. Paano makakuha ng wala yan. Hindi ka makakabuo natin.
Sir, ulit kasi siya dati ma-advance. Nung Zoom natin, ano mo yun, no? Kakapin mo.
Ilan?
Yun.
Ito lang, ito?
Meron na pa niya. Yung mga, ano,
Right.
nakuha mo. Bigyan ko si Jun.
Ay, hindi na rin tayo ng
More or less about 20
Sa amin,
to be
tayo ng
resin.
Bigyan siya. Tagal kasi niya mag
So equivalent to
sa amin yun. Hindi, nung bago na sila papunta dito, yung Zoom na.
about 600 liters,
Meron na.
600 to 650 liters. Okay. Let's say I take 20.
Alam ko na kayo. Kailangan mo.
20 times 20, 35. 700
By friend
kilograms
sa'yo yan?
divided by,
Sinadyan sa'yo yun. Ha?
we can treat, after we generate, we can treat almost close to 60
Inupin ko lang.
kilogallon
Okay.
of water. About 220 tons of water can treat. So, and then based on the 59, less than a day, maybe about 18 hours, 20 hours, 20 hours per generation. Okay. So that's why we need to tell customer that, oh, maybe we need to reject more often. So if such case, 3 tank, not big one. Not big one. Yeah, and then 2 tanks. Because this one can last for 20 hours, for example, and then this one standby, and then we service. Okay, this one regeneration, and then standby. Almost regen every day per tank.
Para sa kanya,
Yeah.
continuous operation.
Alternate.
Pero kung water station na,
don't consider bigger one because you lower the velocity. Then you lower the velocity may happen with channeling. Channeling may cause big problem because some of the resin may be some of the water is just very direct passing through the resin, but actually they are not really doing the so-called ion exchange.
So just add another.
Yes.
But only for the resin we can do that, sir. Not for the
Automatic mag-open yung sa
after passing through that chemical carbon, it will just either go to one container or another.
Yeah.
para may tayo ng generate
Yeah.
production.
So
Yes.
you stated that if we go for the softener unit, so we will also enable the PCF and the net or sun.
You also what? Say again.
Add another tank for PCF and not just the softener.
Okay, it depends of course because this unit need to be checked almost every day, every 20 hours after calculate. But if your system, if your RO which is no buffer, cannot stop almost 24 hours, so you may, or maybe you just shut down in a very short period of time, allow you, then you can, that's why I mentioned this is a good purpose for water treatment design, for water treatment system application. Okay?
Ito mo may kliyente. Bakit nahirapan natin?
Oh, bad debt, okay. Bad debt, when we talk about the ion exchange, normally the height, the bad depth, not less than 24 inches height. Normally we design from 30 inches to say, okay, it's okay. Somehow maybe some sort of a little bit more resin, that's fine, because I would like to get the capacity. For the back washaway, this time in here, the water temperature more or less the same thing, right?
Kunin ko.
So that's why we design the resin, can resin, 5 ppm. But some high temperature area, we need to increase the designing the coverage much more bigger. Low temperature, but here, maybe we just stick on 5 ppm. Okay, the prime related to the how many resin inside the softener, and then we select the proper valve and proper injector. You well know about this one, the sequence of the regeneration. Okay, the whole cycle, regeneration cycle. And in the market, maybe some, maybe flavor all with refill first. Refill at the end. Refill at the end. You going to what? No. So, have you ever paid attention to the prime tank? The sizing of the prime tank, you just, I'm hitting it equal with the prime tank and then that's it, right? And then wash hand, But actually, by technical what way, prime tank should be, for example, if this tank 36 inches diameter, your diameter of prime tank more or less at least same diameter as the same.
Oh.
More or less the same or even bigger. Of course, I just undersize the prime tank, maybe yes. If your end user didn't complain you, I need to put the, yeah. Good design prime tank, maybe we put maybe at least reserve for 2 times we can. Sometimes for home, we reserve more than maybe 5 times, 7 times redemption. Of course, for industrial, we reserve the prime tank, we put the salt inside, right? At least give them 2 times. Yeah, for redemption. You know how many 1 pound, one gallon of water can dissolve how many pounds of salt? You have any idea? 1 gallon you can dissolve to become a saturated brine, more or less about 3 pounds. 1 gallon, 3 pounds salt. Yes. Yes. To become saturated brine. So you can easy to measure the brine tank, the size of the brine tank. Calculate this, the size. You can read it, you know. I think your hand you have this. 2015 will be good enough. However, the backwash will be not enough. Somehow you need to compromise. Because the backwash, not like a sand, medium, very heavy. So maybe done the steps to 8, maybe it's still okay. But you need to well know about your design. Sometimes you need, because from 2015, suddenly jump up to 3150, which is very high jump. Your cost becomes too big. So, but you need to understand your whole design. Somehow, okay, I have no choice then over using 2050, but you need to fully understand the carbon may not backwards as good as the original design. Somehow, you know, I understand if somehow you're going to pick it. Any questions?
I have this certain relation before. My FRP tanks was 16 by 65. Newly rehabilitated, and have proper backwash with
Sand or carbon?
yeah. But after doing that, we tested the output of the water softener. It ranges only from 120 to 250 hardness. It doesn't go below 0. I expect more than.
Okay.
Yeah, that's my problem.
Hot manual or sun?
Well,
New install or the replace the resin, right?
yes, I
Newly
replaced the
replaced the
rest.
rest.
I use
Okay.
the Purolite that I.
Okay. There are a couple reasons, maybe.
Yes.
The bar body, there's the riser tape. Inside there's an O-ring.
Yes.
Maybe your riser tube is too short
Okay.
and then cannot really engage passing through the O-ring. Short circuit a little bit. Cause you still
Going through.
yeah, a little bit.
Well, we don't change the O-ring. I think the riser.
So that's why you didn't check, but you put back the O-ring may be damaged.
Okay, you have to check.
The O-ring damage, and then cause you right now your situation. And then replacement, replace the resin, the riser tube, and then get the O-ring. Always have a problem. Because somehow they broken the O-ring inside All these one inside there's O-ring, right? Yeah, the center there's O-ring. The damage, the O-ring stretch, a little bit bypass of the hot water. So that's why the outlet, you will keep continue to have a certain degree of the colors.
Pass through.
Yeah, bypass, kind of bypass. Any other question? Feel free to ask.
Sir, because we have a customer who is requesting to supply a 5 and 10 GPM souvenir.
5 and 10 GBM, two systems.
Yes, sir,
Okay,
but different customer.
okay.
But
For home, for
industry,
industrial, okay.
but before you state that 5 GPM, right now I brought the Fleck, that's really different customer. Is it possible, sir, that you can supply with them at that capacity, not bypass type? What I mean the bypass type is the piston.
What, 5 type?
The white one, I think that's the bypass type.
Okay.
Yes, sir.
You want to get the bypass piston or no
No bypass. 5, 10, and 50 GPM at no bypass.
And 10 GPM or small valve there.
Yeah.
Small valve maybe only 5600. You make auxiliary switch, add solenoid, or this kind of stuff only. If small valve, no choice. No choice. Our piston cannot, our single piston cannot direct or especially for 5600, no way. Only maybe if you can add the auxiliary switch, 5600, and then the auxiliary switch provide a signal to flow outlet. You also install, you need to install a certain one in order to make it the system. It's a small system because our current small valve mainly for residential applications. Residential application we need to has to be a bypass. No simple way. No simple way.
I think
Only available on the
It's all about money.
Hindi ko nakakabili ka ng competition.
My nose is bleeding right now.
Just like what I said, this is the bloodiest day. This is the bloodiest day.
yung mga technique natin dito.
Yeah, yeah,
No,
yeah.
this one and
This one, this one.
Ah, this
You
one.
check with the,
Yeah.
you will have a connection.
Ang inaano lang namin kasi pagka bumili ka ng seminar, mas mahal. Kaya pinaka-best
You need to wiring, you know, connect with the solar, connect the power supply to one wire trigger, and then let's say which two contact, and then okay, power to solar.
Ano?
Close.
Ano kailangan ko?
Normally close or not.
Doon.
Dapat normal i-close yan. Pag again, activate siya.
I think you
Normally open. Normally open. Kasi pag...
normally when it's weak, normally you pick better because normally open meaning energize the close is better. Yeah. Because it's just only MC on there. Okay, so that's why you buy the normally open. Power here connect together once you trigger. Contact. Big power. That's all not open.
The wire of say will be this one. Oh, is it okay if we use this and then run to commercial or no?
So, okay.
So it has to do. Is it okay?
Solder.
Yeah.
Yes, normally using the quick on.
Ah, okay. Ah, I have to buy this one. So I can put
Yeah.
directly. Okay.
Just go to the hardware store, for the wiring terminal. You just try it. Okay.
Ay, meron pang tayo. Not right.
ayun lang microchips.
Ah, yun lang.
Yung parang stream. Ano natin? Usually, di ba, problem sa
Small, tiny, the same size, except for way
Sir, balik lang ako, sir, ah.
cannot take this way. I always can
Pwede mo. Busog ba nga ako? Anak kinain ka na.
Hindi na kami assist na.
Ay, grabe naman.
Pero ang bukas pa. It's sa 23.
November 23. Sino naman yun? Hindi na rin.
Yan gawin mo. Simpulan mo lang dyan.
Maybe a couple reasons. As I mentioned before, if always, if a couple time always mistake that maybe underside, maybe the product. You can then right now we all want the market is using standard ejector suction. That ejector already stands for one specific cycle setting. For example, right now they get one is one maybe for good for 12-inch tank, for example. Good for example, good for 12-inch tank. But right now you have to apply this one apply to 16 inches. And not enough salt for regeneration, so that's why we do have salty water. No, sorry, hot water. Maybe.
Dami bang charge? Dami pa naman. Naka-charge ko yun kaya. Hindi ka ba naman? Zoom na yan.
Just the thing, all these kind of
Ano yung pang-missing sa pag-iugas?
Nabasa ka mo kasi pero sa kanila.
Potable na radio.
Parang nagpupusok ng
is the review amount of review volume.
kailangan lagi naka-straight lang. Lagi naka-straight. Nag-lock siya, oo. Naka-strain lang ano na movement. But this is our program. Hindi namin na solution. Solution kasi hindi nila pwede. Sabi ko sila ako yung hindi mo sana yung ganyan. Sana yung
Tinawag mo? Si Alma? Sino?
Hindi pa pinapasutin yan pag how many years?
So review the
Hindi, pero ganun ba yan? Ay, hindi mo eh. Ano siya, no? Compound fracture. Compound fracture ba? Kaya pinalitan na talaga.
Tingnan mo.
I think
Yung tao.
we have to
Nakita sa akin, ano yung masabi ko? Masabi.
concern
2 seconds.
2 seconds eh.
all the people.
Oo, hindi mo nag-release sa akin.
And then,
Kaya ang bata, oops.
may isa pa sir, then what will probably the solution of that? But sir, we feel going to all the people. If you want to put this on the okay, want to be sexy. Yung diet. Okay. Oh, yeah.
Sa table ko.
Ha? Ano sa room natin? Inilagyan ka.
Eh,
Sa rest day.
Sexy.
Binigyan mo ba doon?
Bawalin mo na.
And in troubleshooting, we will not just only relate to our other troubleshooting, let's say. For example, backwash. Let's give an example. Example. Because of the improper sizing the drain line, please backwash they didn't put the drain line okay, for the current filler, AC filler. Once they backwash, high flow,
Nilalangan mo yun o yung
first 2 minutes, more of the drain pipe, a lot of water. And then after that, normal small flow. Very small amount of flow. Meaning, they actually carbon floating up,
Kaya ka na-equip sa ganyan.
block.
Kaya nga lang.
So that's why in drain pipe, almost very small block. So that's why this kind of commission, you need to pay attention to this because of Okay. So there are so many these kind of kasi meron na akong nakikita sa mistake, but for installation, always like to put inside the skin on the skin. So maybe cannot be too tight. Cannot be too tight. You need to have some buffer, some rubber in order to put it as a buffer. Because every time you put his hands.
Maybe yan, magkano? 10,000. So hindi mo na ginagawa ng ganyan ngayon. Kung marble, pwede yun. Kaya na ba automatic?
Install in and out.
For example, if all rigid pipe, especially big tank, in and out, and then you wall, and then the pipe go here, and then go inside, for example, and then you work all of it very tight, very thick. No room for the once you put tank pressurized, bigger, and then this one push the tank. So that's why we sort of flexible type, how to learn what especially for the tech neck, I mean the friend.
Just PPR, so PPR 5 here. PPR is
Yeah.
also
Okay, that's good. I just mentioned, I want to mention, and then rigid. Oh, rigid line, that's okay. Metal line, copper line.
for the using that technique.
Okay. So, you have any? Do you have any question?
Feel free to share to us.
Oh. No question?
No question.
Violent reaction. No more question. Violent reaction. Maybe, sir, we can tackle some of the problem or the concern in regards to the other clients. And then show to everybody what would be probable cause, what is the probable cause and the solution for that matter. Maybe we can show it to all of us. Yeah, yun. Hindi nga nila ginagamit.
So one of the clients asked a question about the piston type because he wants to have a softener valve that has no bypass piston. But the one that he bought the valve that came with the standard piston. And so he wants to do a conversion. So the client wants to convert the existing valve that they have from a standard piston to one that has a no bypass because he doesn't want any hard water moving downstream of his process during the regeneration cycle. So there's two ways to do it. He can either change the piston together with the seal and spacer, or he can on auxiliary switch and then together with a solid valve mounted at the outlet of the valve. Then during the regeneration cycle, the cam will contact that auxiliary switch to give a signal to energize, to close the outlet. So that will push.
Can we show it into the board? How does it work? Yeah, I mean the schematic flow. How can we install that?
NC, the wiring.
The
Together with the wiring.
wirings and the pipings. How can we install the solenoid or any bulbs on the
Depending on the valve, some of them have it, and some is can be added on as an accessory. So in this case here, it's a 2750. It comes with the mounted. There is an auxiliary switch here, already mounted on the brine cap here. So whenever it goes into the regeneration cycle, this brine cam will take and it will activate the arm of the switch here. And then depending on the wiring, the sensor's drawing it now. if you have installed the solenoid valve on your outlet that is normally open, energized to close. So during that contact, it will give the electrical signal to close the outlet. That will give you no bypass function, because now the hot water is not able to go out downstream. So this is the one of the uses of the microswitch or auxiliary switch. And also can be used on a filter to activate a backwash pump. Okay. Then when the valve goes into the backwash cycle, again it will use the switch to signal the pump to on. Yeah, so this can be added on as a optional accessory, that instead of changing the piston. Yeah.
So you don't motorize
So for different valve, the mounting position of the microswitch is in a different. For every valve is a different position.
From sa head mismo. Yung head mismo.
head mismo.
Head mismo. Kung equip siya sa ganun.
Oh, kasi may ano naman yan. May microswitch.
Nasa loob yun.
Nasa loob yun. Normal close ko siya kapag loob. Usually kasi normal close na kapag loob.
Ayun,
Hindi, coil lang. Coil lang.
kaya niya patayin mismo yung araw na yung switch. Patayin niya. Kailangan na ano. Anong makibay mo rin?
Hindi lang. Kailangan.
Ayun lang ang problema.
Kailangan mo na.
Yung vacuum breaker, use lang.
Backup.
Maganda na yung
Akin tumatakbo siya. Sumablade na siya.
Kailangan mo pa rin ba?
magkano lang yung function. Problema na naman. Kaya tayo maganda ng seminar. Conventional na lang lahat.
Nakita, no?
Here you go the simple drawing for the solenoid valve. Actually, you need to define for outlet to become low bypass. You need to select the solenoid valve with normally open.
Normally,
Normally open valve. Okay. This is a micro switch.
Taas to, eh.
Micro switch. We check in case we start regeneration, we trigger. There's a command, normally open. Once you
Mataas to, eh.
contact,
Mataas to.
link up together, energize the solenoid. And then this one, once regeneration, this one close. Because normally open, right?
Magkocontact yung switch niya para magsara yung sunog.
Okay?
disconnect.
Understand? I'm not good at the quick sound drawing, but I try my best only. The logic is correct.
Yeah, that's fine.
Oh,
Okay, wala namang masira na. Ayaw na tayo.
And sir, can we apply this to this
Paano na si Pedro at saka si Juan?
one to our own?
Nabagay
That,
mo na.
if the head and the R of mount to each other.
Hindi, ilalagay mo ito. Sa complex na pagkina. Hindi, sabi mo, may bagong technology.
In order for not to
Doctor.
to control. So this all in up with you need to set up a control system instead. So okay, this simple, low M, easy to direct connect, but it will be related to connect to the hour control or switch off the pump if in case any system, any softener or maybe send to the regeneration, interlock the RO, make sure that the RO which is in switch on position. Yeah, can do, easy. I want to remind you, somehow you will RO tank, right? You store the RO water, right?
Yes.
If high level, what happened? Shut off what?
The RO pump.
RO pump, and then shut off. You shut off the water pump?
Yes.
Sometimes yes, right?
Yes.
Pag namatay yung araw, sasarating.
However, most of the time they shut off maybe nighttime. When you design this kind of circuit, shut off water pump, I just remind you, remember, if any pump, any system start regeneration, you need to trigger the pump to start turn on. Otherwise, your high level already call the pump switch off. So this unit never do any regeneration during midnight. So this control logic, you need to really pay attention, especially for water tank, water storage tank, high level, you call the water pump switch off, depends. However, you need to also need to how to call this pump turn on if sand filter start regeneration. All are related to operating. Someone suddenly called, hey, Stella, what happened? Why? Most never do the regeneration because of the wrongly applied. And then they call me. Actually, it's not my fault. Actually, it's not my fault. Because they wrongly designed, they wrongly put the wrong concept here. Yeah, we can discuss more. Because sometimes I forgot and then maybe I suddenly I think something that may be good for you. Just discuss, only discuss. Because I know you do a lot of the power system. Maybe
Ibilin mo na lang sa anak mo. Magpapalit ka ng head dito. After 10 years after ng pagkamatay ko.
Hindi mo na makakasa ng presyo. Yung magalang ganun.
drain pipe,
Drain pipe.
small system. For example, this example, there's a drain pipe, never direct connect with your main drain. Never. You may using a flexible tip. Flexible tip, yes, okay. There's an air gap. Good. Make sure there's an air gap. Make sure there's an air gap. Okay, good. And not without, I want to make the system look nice. Maybe the end user request, I need the rigid pipe look very much more nicer than the flexible hose. So, but if all connect together, very high chance. The webcam. Yeah. If all hook up together without air gap, high flow, full pipe, this pipe, make great webcam.
Hindi mo ba?
Kung nangyayari, kung mawala ng tubig yung
Kabila.
tubig. Pero
So that's why I make sure that if you, even though this system don't need to install the vacuum breaker, but with the air gap, fine.
Vacuum.
check
Vacuum
valve.
breaker.
Ay,
Vacuum breaker.
ekip. Ano
Yes,
yun?
I think the shop is constantly
Vacuum.
about
Vacuum breaker. Vacuum breaker.
Check balance.
Check valve.
They say like,
Check
no,
valve.
Check valve. Yung ekip na check valve. Sabi nga, ano ba yung ekip? This you know. Sinisinok eh. Di ba pag nasa brand ng tubig, sinabakan? Brand ako piyesa yun eh.
Check valve.
Brand ako piyesa. Hindi ko alam.
Check valve.
Hindi, pero mas sinabi mo check valve. Hindi nga siya.
Very close. The dust inside the shell is very sensitive, even though low pressure.
Bigay lang ng presyo.
Valve na lang. Valve.
Bag na lang, bag na lang.
Oo.
Hindi, magtatara ka. Pero nung pitik sa ano, yung may bola.
Check valve pa rin.
Oh, check valve bro. Mas mura yun.
Oo. They mention what kind of valve they going to use on that particular drain system. So they mention check valve is an option or a valve or anything that can protect the system from vacuuming
During the backwash.
backwash procedure.
Considering the drain system.
Draining system.
No, valve, check valve,
Check valve.
Check valve.
check valve, because it's not check valve, which is we designed for water. We designed the check valve which is for water applications. Because right now, we would like to have the vacuum breaker, which is related to the air. Once you vacuum and then easy to open, and then allow the air go in. However, if your check valve, which is they design the mechanism, the spring inside the spring inside the check valve, which will be too strong, the air may not able to go inside. Yes, maybe the vacuum not high enough to push the spring. So this one may not be a good device, but it was
Another check valve. Like that.
maybe yes, maybe yes, maybe yes, maybe okay.
Where is spring? Alam mo, spring.
Swing valve ball.
Hindi, yung spring dito wala siya.
Swing valve. Swing valve. Swing valve.
Oh, swing. Hindi ba? Pero pwede mo.
Pero
they put the valve in the drain. In the drain.
Yeah.
any question?
Question time.
Question time. This is a question time. No question?
Even personal question, it's okay.
Oh, that's fine. If you want to ask some personal question, that's fine.
Are you married?
That's what I'd like to ask Yishan. Are you married?
Hey, that question is too awkward for a man to ask.
Okay.
It should be a woman.
Any
I will share about the injector, because I know that because the box that is stocked by Shanghai.
Create a webcam or the prime solution because of the pressure going inside the residence. So very important, make sure enough pressure, minimum 40 psi, 30 to 40 psi. If pressure too low, will be a problem. If your system just only 20 psi, boom, maybe no brine can go into the system. So that's why all related to the pump. All are limited to that. Yes. So ejector, this one need correct pressure. The best 40 to 60. 40 to 60, which is the best pressure